All right, chapter 10 is all about forces. And forces, as we mentioned in chapter 9, can be represented by vectors. A vector is an arrow that has a magnitude and a direction, or an amount and a direction. In circular motion involves rotating around a main center point. There's two forces involved, an outward force, which is centrifugal force, and an inward pull, as in this case from the rope, that is called a centripetal force. It sounds the same, but it's different. So there's an inward pull, pulling from the rope, pulling on the ball, and an outward force of the ball trying to get away from the guy that's swinging it. Any kind of motion can be represented with a series of arrows that we really looked at last week. And here's a diagram right there about a mountain climber who's got a force of the rope pulling on him, the force of gravity pulling down against the rope. Same thing with the airplane in the lower left. There's the force of lift that we'll be learning about at the end of chapter 10 that is pushing up on the airplane wing stronger than the force of gravity pulling down. That's why the airplane rises. And the thrust from the propeller pulling against the molecules of air, and the drag or friction created by those molecules of air pushing against the airplane. And the rock on a hill, potential energy, if it's moving, there's a force moving downhill. There's the force of gravity, there's the force pushing back up of the hill on the rock, and then there's the frictional force moving backwards towards the hill, up the hill. So analyzing forces on objects, there may be 4 primary forces on one object, and you can go ahead and write this down. There's gravity, of course. Gravity is pulling down towards the center of the earth on all objects. There is the force of friction that is moving against the direction of motion of an object, and that is the force that the object is contacting, pushing against in opposite direction of motion. And then there's 2 types of elastic force that we're going to be looking at. There's tensional, which is pulling apart, and compressional, which is pushing together. Tension is pulling apart, compression is pushing together. 2 types of elastic force. Now, we'll study each one of these in turn. Okay. A force is equal to a push or pull. So a force is any push or pull on an object. You don't have to write this one down. A force is any push or pull on an object. And forces are vectors, so they have both a direction and a magnitude. And when forces are balanced, all the forces on an object are equal and balanced to each other in opposite directions. And the motion of the object does not change. So a stationary object has balanced forces acting on it. Now, do you remember the word reference point? Oh, come on, guys. Okay, look at my coffee cup. Is my coffee cup sitting right there moving? No. That's relative to what reference point? Me, the wall, whatever. Now, if I asked you ultimately is that coffee cup moving, what would your answer be? Okay. Because the Earth is rotating and spinning around its axis. This coffee cup is both going this way because of the spin of the Earth every 24 hours, and it's moving at 23,000 miles an hour around the sun. So relative to the reference point of this classroom, yeah, the cup is not moving. However, if you look at the reference point being the sun, yeah, it's moving. Tommy?
How fast is the Earth rotating?
20. So it rotates a whole 360 degrees every 24 hours. That's called a day. And then it rotates around the sun. It takes 365 days to go that entire distance, and it's going about 23,000 miles an hour. So there's a couple different types of motion going on there. And actually the spin of the Earth is not, as you might imagine, we'll get to this in chapter 13, but it's not spinning around a stationary axis. That axis is actually wobbling. Yeah, exactly. It's like a cone, and I'll tell you more about that. Yeah, Spencer Law. It's about 23,000 miles an hour. Yeah. Okay, the units of force. The basic unit of strength of force is the Newton. And newtons relate mass to acceleration. So remember I told you that at the beginning of class today that to understand force, you really have to understand motion. And the type of motion that we're talking about is acceleration. That it is related to the amount of mass that an object has. And that is called momentum. We'll get to that. The units of the Newton are kilograms, meters per second squared. So that's a strange unit. It has to do with mass combined with acceleration. We know that mass is measured in grams, kilograms, and so on. We know that acceleration is measured in meters per second squared. And so the units of these newtons are kilograms, meters per second squared. And 1 newton is about equal to lifting a mass of 1 small apple 1 meter straight up. So the amount of force involved in lifting that apple 1 meter is about 1 newton. Yeah, Annie. No, I just wanted you to write that segment down, and then there is a video of this lecture online if you need to review it. And the PowerPoint is online as well, or the Keynote. Okay. Combining force vectors. We did a little bit of this in chapter 9. Net force results from combining vectors, and the strength and direction of the individual forces determine how much the net force is. Calculating it, how do you find the net force when 2 forces act in opposite directions? Well, if you look at 2 forces acting in the same direction, 5 plus 5 is 10, so the overall net force is 10 newtons. Opposite directions, you're going to be subtracting. So 5 minus 7 is negative 2 newtons. So the net motion of that is 2 newtons to the left. That's how you would describe it. And if the forces are balanced in equal and opposite directions, there is no motion. They're balanced out. And here's an example of what balanced forces look like. Balanced forces produce no overall movement if they're acting in opposite directions. So the 2 people pushing it with equal force but in opposite direction produces no motion. Unbalanced forces, on the other hand, produces movement, a change in speed or direction. So 2 people pushing in the same direction, you would add their force vectors to find out the total force that they're both pushing. 2 people pushing in opposite directions but unequal force is going to produce motion in one direction. And in this case, it is 100 newtons to the right. You would just subtract those 2. Yeah, Jackie Mai. Yeah, you can write newtons as long as you understand that the units of a newton are kilogram meters per second squared. Yeah, either one of those would be appropriate on a test. Okay, that's it for today. Yes, Jackie Mai. Yes, exactly. Yeah, they are equivalent.